Physics is about describing the real world and predicting the real world and understanding it. And you can only know if you're doing that right if you've got some way of saying exactly how right you are. Normally when we talk about reality, we talk about it in qualitative terms. We talk about it being hotter tomorrow than it was today, or sunnier tomorrow than it was today. But what physics tries to do is really give a quantitative meaning to those words. So to do that, you need to be able to give a number to say how much hotter. And once you've given a number to it, it's something that you can check as well. So if I say it's going to be 2 degrees hotter tomorrow, you can look at the thermometer and tell me, well, no, actually it was 4 degrees hotter and you were wrong.
I think one of the hardest parts of research is not so much trying to solve a problem as figuring out which problem you're going to solve.
Comment ça marche exactement?
Alors, bon, ce qu'on a MCFM nous donne Z plus 0 jet at next to leading order. Et dans le cas de 1, sort of n legs en plus du Z. À chaque ordre, comment faire pour générer ce terme-là?
Sometimes, yes, I get demotivated when I'm stuck somewhere and I can't solve it for 2, 3, 4 days. And there, I think it's okay. Sometimes I almost want to give up everything.
Theoretical physics is, to some extent, a solitary thing, and that's one of the more difficult bits of it. People have different ways of working. Some people do work more in collaboration, others work more on their own. And that's something that evolves through one's career as well.
If you are not prepared to it psychologically, you just have to give up. And what I have to learn is how to deal with such situations.
Part of solving a problem is believing that you can solve it and having the persistence to sort of think and wait and think and come back to it until you do find the solution. And just the fact that you know that whole process does actually go somewhere is an important part of solving problems. It's the belief that you can get there.
I mean, the question is, in a real particle physics event, you've got hundreds of particles, and most of the particles just go in the same direction. A whole bunch of particles going in the same direction is what we call a jet. As theorists, we try to describe that with just a handful of particles. You replace that whole jet with one gluon or one quark. And so rather than talking about hundreds of particles, maybe you talk about 3 or 4 quarks or 3 or 4 gluons. What we're trying to do is predict what events will look like at LHC.
The LHC at the moment suffered a sort of an engineering breakdown, and now we're just waiting for the repairs to be finished, or rather, well, the whole community is waiting for the repairs to be finished, but in particular the experiments are waiting for that before they sort of start sending round beam again and actually have collisions.
Probably not allowed to say blown up in anything that's public.
No, that's right.
Probably supposed to use a word like...
If the LHC hadn't had a glitch.
We had an electrical failure, let's say
a minor technical malfunction.
No, not minor.
What happened is that we had an arc which developed in the superconducting cable, actually in one of the interconnections.
where a high current carrying conductor for reasons that we do not understand fully yet still, arced.
Which actually punctured the helium circuits. So we had cold helium which actually passed to the cryostat insulation vacuum.
Of course, sitting at 1.9 degrees Kelvin and it warms up, becomes gas, and there's a huge volume ratio from liquid to gas.
Catastrophic release of helium, of liquid helium, large release of liquid helium which expanded very rapidly.
Yeah, yeah.
We think we will be able to finish end of April the preparation of the last magnet for being introduced into the tunnel. Then we have to go on connecting the magnets inside the tunnel and then going through all the commissioning phase before we can really start powering the magnets again and start up the operation of the machine. And that's why this will take from about April, beginning of May, up to September for the real start-up of the LHC once again.
Music has many different frequencies, or if you like, there's many different notes. And sort of as you go higher up in pitch, it's a bit like going higher up in energy at the LHC. And you can imagine what particle physics is trying to do is, there's a piece of music playing. So the theory of particle physics still remains to be found out. And with the machine that existed previously, the Tevatron, it's like trying to identify that piece of music when only the double basses are playing in an orchestra. What the LHC will do is add in the cellos. And from the cellos and double basses, we're trying to figure out what the theory is that's behind particle physics. And what the rest of the orchestra is playing.